Hi guys, welcome to my study compass. In this video, I'll be walking you through Math P4, the specimen paper for exams from 2020. Let's get started. Christian and Stephanie share some money in the ratio 3:2. Christian receives $72. Work out how much Stephanie receives. In the setup, we've noted the ratio in which Christian and Stephanie share the money. If Christian receives $72, then how much does Stephanie receive? This is what we are calling X. From the ratio setup, we can cross multiply and make X the subject. This gives us X equals 2/3 times $72. When we type this into the calculator, we get $48. Christian spends 45% of his $72 on a computer game. Calculate the price of the computer game. To get the price of the computer game, we multiply 45%, which is the same as 45/100 by $72, which is equal to $32.40 rounded to 2 decimal places. Christian also buys a meal for $8.40. Calculate the fraction of the $72 Christian has left after buying the computer game and the meal. Give your answer in its lowest terms. This fraction will be equal to the amount of money Christian has left, which is $72 minus the sum of $32.40 and $8.40 divided by $72. When we type this into the calculator, we get 13/30. Stephanie buys a book in a sale for $19.20. This sale price is after a reduction of 20%. Calculate the original price of the book. Since $19.20 is a reduction of 20% on the original price, we have 80% of the original price equals $19.20. When we make OP the subject, this is what we get. When we type this into the calculator, we get the original price as $24. Boris invests $550 at a rate of 2% per year simple interest. Calculate the value of the investment at the end of 10 years. The final value of his investment would be equal to his principal plus the total interest he earned. Since he earned simple interest on the principal, the total interest can be calculated using this formula. P is the principal, that is $550. R is the annual rate, and that is 2%. T is the time duration in years for the investment, which is 10. When we type this into the calculator, we get $660. Marlene invests $550 at a rate of 1.9% per year compound interest. Calculate the value of the investment at the end of 10 years. For compound interest, we can calculate the final value of the investment using this formula. Big A represents the final value of the investment, which is what we are finding. Small a represents the principal, which is $550. R is the annual rate, which is 1.9%. And T is the time duration in years for the investment, which is 10. When we type this into the calculator, we get $663.90 rounded to 2 decimal places. Hans invests $550 at a rate of X% per year compound interest. At the end of 10 years, the value of the investment is $638.30, correct to the nearest cent. Find the value of X. Since we are dealing with compound interest in this case as well, we need to apply the compound interest formula. The annual rate has been given as X% and we want to find the value of X. When we make X the subject of the equation, this is what we get. Big A represents the final value of the investment, which has been given as $638.30. Small a represents the principal, which is $550. T is the time duration in years for the investment, which is 10. When we type this into the calculator, we get 1.50, rounded to 3 significant figures. 200 students estimate the volume V meters cubed of a classroom. The cumulative frequency diagram shows their results. Use the graph to find an estimate of the median. To get the median, we map half of 200, which is 100, on the diagram. This gives us the median to be 400 meters cubed. Use the graph to find an estimate of the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. To get the upper quartile, we map 3/4 of 200, which is 150, on the diagram. This gives us the upper quartile to be 420 meters cubed. For the lower quartile, we map 1/4 of 200, which is 50, on the diagram, giving us 350 meters cubed as the lower quartile. So now the interquartile range is 420 minus 350 meters cubed, which is 70 meters cubed. Use the graph to find an estimate of the 60th percentile. To get the 60th percentile, we map 60% of 200, which is 120, on the diagram. This gives us 408 meters cubed. Use the graph to find an estimate of the number of students who estimate that the volume is greater than 300 meters cubed. On the diagram, when we map 300 meters cubed from the horizontal axis to the cumulative frequency graph, we get 30, which is the number of students who estimate that the volume is 300 meters cubed or less. Therefore, to get the number of students who estimated that the volume is greater than 300 meters cubed, we subtract 30 from the total number of students, which is 200. 200 minus 30 is 170. The 200 students also estimate the total area, A meters squared, of the windows in the classroom. The table shows their results. Calculate an estimate of the mean. You must show all your working. The mean is equal to sigma f of x, which is the total sum of the areas estimated by the students, divided by sigma f, which is the sum of the frequencies. To get sigma f of x, we first need to calculate the average area for each of the given area intervals. For the first interval, the average area is 20 plus 60 divided by 2, which is 40. Then we have 60 plus 100 divided by 2, which is 80. 100 plus 150 divided by 2, which is 125. Then finally, we have 150 plus 250 divided by 2, which is 200. So now sigma f of x is 40 times 32 plus 80 times 64 plus 125 times 80 plus 200 times 24 divided by 200. When we type this into the calculator, we get the mean as 106 meters squared. Complete the histogram to show the information in the table. To be able to draw the histogram to show the information given in the table, we need to calculate the frequency density for each of the given intervals. The frequency density is equal to the frequency divided by the interval width. For the first interval, the frequency density is the frequency, which is 32, divided by the interval width, which is 60 minus 20. This is equal to 0.8. Then we have 64 divided by 100 minus 60, which is equal to 1.6. Then we have 80 divided by 150 minus 100, which is equal to 1.6. Then finally, 24 divided by 250 minus 150, which is equal to 0.24. This interval has already been drawn on the histogram for us. So now, after marking all the different intervals on the horizontal axis of the grid, we can map out their heights using their frequency density values. 2 students are chosen at random from those students that estimated the area of the windows to be more than 100 meters squared. Find the probability that one of the 2 students estimates the area to be greater than 150 meters squared and the other student estimates the area to be 150 meters squared or less. For this probability, we have the probability that the first student estimates an area greater than 150 meters squared and the second student estimates an area lesser than 150 meters squared. The order in which the students are picked can differ. Due to this, we multiply this probability by 2. We need to remember that these students are picked from the pool of students who estimated an area greater than 100 meters squared. And so the probability that the first student estimates an area greater than 150 meters squared is equal to the number of students who estimate an area greater than 150 meters squared, which is 24, divided by the total number of students, which is 104. After the first student is picked, the total number of students is now 103. And so the probability that the second student estimates an area of 150 meters or less is equal to the number of students who estimate an area of 150 meters squared or less, which is 80, divided by the total number of students, which is now 103. When we type this into the calculator, we get 0.358 rounded to 3 significant figures. F of x equals 20 over x plus x, where x cannot be equal to 0. Complete the table. When we substitute x equals 5 into the equation, we get y equals 9. And for x equals 8, we get y equals 10.5. On the grid, draw the graph of y equals f of x for x is greater than and equal to negative 10 and less than and equal to negative 1.6 and x is greater than and equal to 1.6 and less than and equal to 10. So on the grid, we plot all the points in the table and draw a smooth line passing through the points. Using your graph, solve the equation f of x equals 11. To do this, we draw the line y equals 11 on the grid and note its intersection point with the curve. When we read the x coordinates of the intersection point, we get x equals 2.4 and x equals 8.4. K is a prime number and f of x equals k has no solutions. Find the possible values of k. On the grid, f of x equals k are the horizontal lines that do not intersect the graph of f of x at any point. Since k can only be a prime number, the possible values for k in this scenario are 2, 3, 5, and 7. The gradient of the graph of y equals f of x at the point 212 is negative 4. Write down the coordinates of the other point on the graph of y equals f of x, where the gradient is negative 4. The gradient of the graph at 212 is the slope of the tangent at 212. We want to find another tangent on the graph that has the same slope, or in other words, a tangent parallel to this one. We see that the only other point where the tangent has the same slope is at the point -2, -12. The equation f of x equals x squared can be written as x cubed plus px squared plus q equals 0. Show that p equals -1 and q equals -20. We know f of x is 20 over x plus x. When we multiply through the equation by x, this is what we get. When we send all the terms to one side of the equation, this is what we have. When we compare our equation with x cubed plus px squared plus q equals 0, p is the coefficient of the x squared term and that is -1. Q is the constant term and that is -20. And so we've been able to show that p is -1 and q is -20. On the grid opposite, draw the graph of y equals x squared for x is greater than and equal to -4 and less than and equal to 4. This is a quadratic function, and we know quadratic functions have a parabola shape. Let's pick some sample points to plot this graph. When x is 0, y is 0. When x is 2, y is 4. And when x is -2, y is 4. When x is 4, y is 16, and when x is -4, y is 16. When we are done plotting the sample points, we draw a smooth line passing through the points. Using your graphs, solve the equation x cubed minus x squared minus 20 equals 0. Remember that we arrived at this equation by equating f of x to x squared. This means to solve this equation, all we need to do is find the x coordinates of the intersection point of the two graphs. On the grid, there is only one intersection point between f of x and x squared. When we read the x coordinate of this point, we get 3.2. The diagram shows a sketch of the graph y equals x cubed minus x squared minus 20. P is the point n0. Write down the value of n. At point P, y is 0. So when we substitute y equals 0 into the equation, we have x cubed minus x squared minus 20 equals 0. Remember, we've already solved this equation in the previous question and we got x equals 3.2. This means n is also equal to 3.2. Draw the reflection of triangle T in the line x equals 0. So first, we draw the line of reflection, which is x equals 0 or the y-axis. Then from here, we need to reflect the vertices of triangle T in the line x equals 0. So for point C on the triangle, since we move 2 units to the right to touch the line of reflection, we also need to move 2 units to the right from the line of reflection to pin the new position of point C. We need to repeat the same process for points A and B on the triangle as well. When we are done, we are able to map out the reflected image of triangle T. Draw the rotation of triangle T about -2, -1 through 90 degrees clockwise. First, we need to mark the center of rotation, which is the point -2, -1. Then we rotate each vertex on triangle T 90 degrees in the clockwise direction about this center. This means if, let's say, we pick point B, we draw a line from point B to the center of rotation. Then we measure and mark 90 degrees in the clockwise direction from this line. The final step is to now mark the new position of point B on this line such that the distance from this new position to the center of rotation is the same as the distance from the center of rotation to the original position of point B. After repeating the same process for all the vertices on triangle T, we are now able to map out the rotated image of triangle T. Describe fully the single transformation that maps triangle T onto triangle U. When we look at both triangles T and U, we can tell straight away that this is a translation because both triangles have exactly the same size and orientation. The only difference is they are located on different parts of the grid. So now all we need to do is find the translation vector. From the illustration, we can tell that the translation vector is 1, 9. And so the full description for the transformation will be translation by the vector 1, 9. The perimeter of the rectangle is 80 centimeters. The area of the rectangle is 8 centimeters squared. Show that x squared minus 40x plus a equals 0. Based on this, we know that 2x plus 2y equals 80. And based on this, we know a equals xy. We have two equations and the final equation we want to arrive at does not contain y. So we can take out y by substituting y equals a over x into 2x plus 2y equals 80. When we do that, this is what we get. We want to get rid of the denominator, and so we multiply through the equation by x. This gives us 2x squared plus 2a equals 80x. When we move all the terms to one side of the equation, this is what we get. The terms have a common factor of 2. So when we divide through the equation by 2, we get x squared minus 40x plus a equals 0. When a equals 300, solve the equation x squared minus 40x plus a equals 0 by factorizing. When we substitute a equals 300 into the equation, this is what we get. We rewrite minus 40x as minus 10x minus 30x. When we factor out x from the first two terms, we are left with x minus 10. And when we factor out minus 30 from the final two terms, we are left with x minus 10. This can be rewritten as x minus 10 times x minus 30 equals 0. When we equate x minus 10 to 0, we get x equals 10. And when we equate x minus 30 to 0, we get x equals 30. When a equals 200, solve the equation x squared minus 40x plus a equals 0 using the quadratic formula. Show all your working and give your answers correct to 2 decimal places. When we substitute a equals 200 into the equation, this is what we get. When we apply the quadratic formula to the equation, this is what we get. The numbers under the square root, minus 40 squared minus 4 times 1 times 200 is equal to 800. For the first possible value of x, we have 4 plus square root of 800 divided by 2, which is equal to 34.14 rounded to 2 decimal places. Then we also have x equals 4 minus square root of 800 divided by 2, which is equal to 5.86 rounded to 2 decimal places. A car completes a 200 kilometers journey at an average speed of x kilometers per hour. The car completes the return journey of 200 kilometers at an average speed of x plus 10 kilometers per hour. Show that the difference between the time taken for each of the two journeys is 2000 divided by x times x plus 10 hours. The difference in the time duration would be the time duration for journey 1 minus the time duration for journey 2. To get the time duration for each journey, we divide the distance traveled in each journey by the speed for the journey. The distance traveled in journey 1 is 200 kilometers and the speed for the journey is x kilometers per hour. The distance traveled in journey 2 is also 200 kilometers, but the speed this time around is x plus 10 kilometers per hour. We are subtracting two fractions, and so we get the LCM by multiplying the denominators. which gives us x times x plus 10. X goes into the LCM and we are left with x plus 10, which multiplies the numerator 200. X plus 10 goes into the LCM and we are left with x, which multiplies the numerator 200 to give us 200x. When we expand the brackets, 200 times x is 200x and 200 times 10 is 2000. 200x minus 200x is 0, and so our final answer here is 2000 divided by x times x plus 10. Find the difference between the time taken for each of the two journeys when x is equal to 80. Give your answer in minutes and seconds. All we need to do is substitute x equals 80 into our time difference equation. This gives us 2000 divided by 80 times 80 plus 10. When we type this into the calculator, we get 5/18, which is in hours. 1 hour is 60 minutes. And so to convert this to minutes, we multiply 5/18 by 60. This gives us 16 2/3 minutes. 1 minute is 60 seconds. And so to convert 2/3 minutes to seconds, we multiply it by 60. 2/3 times 60 is 40. And so our final answer here is 16 minutes, 40 seconds. OPQR is a rectangle and O is the origin. M is the midpoint of RQ and PT is to TQ equals 2:1. OP is P and OR is R. Find in terms of P and OR in its simplest form, MQ. MQ is half of RQ. We know RQ is P, and so MQ is half P. Find MT. MT can be expressed as MQ plus QT. From the ratio, QT is 1/3 of QP. We already know MQ is half P and QP is negative R. And so our final answer here is half P minus 1/3 R. Find OT. OT can be expressed as OP plus PT. From the ratio PT is to TQ equals 2:1, we see that PT is 2/3 of PQ. OP is P and PQ is R. And so our final answer here is P plus 2/3 R. RQ and OT are extended and meet at U. Find the position vector of U in terms of P and R. Give your answer in its simplest form. The position vector of U is the same as vector OU. The approach we'll be using for this question is to find two different ways to express the vector OU. Then compare both vectors to be able to fully define the vector OU. First, let's pin the position of point U. We are told that RQ and OT are extended to meet at U. So when we extend both lines, their meeting point will be the point U. One of the ways we can express the vector OU is as a scalar multiple of the vector OT. If we call this scalar multiple x, then we have OU is equal to x times OT. We've already found OT in the previous question as P plus 2/3 R. So when we expand the brackets, we get XP plus 2/3 XR. The second way we can express the vector OU is OR plus RU. RU can be expressed as a scalar multiple of RQ. Let's call this scalar multiple Y. OR is R, RQ is P. So we have OU equals R plus YP. Now that we have two expressions for OU, we can compare the coefficients of P and R to find the values of X and or Y. When we compare the coefficients of P, we have X equals Y. And when we compare the coefficients of R, we have 2/3x equals 1. When we make x the subject, we get x equals 3/2. Since x is equal to y, then y is also equal to 3 over 2. When we put the values of x and or y into either of the equations for OU, we get the same answer, which is OU equals r plus 3 over 2p. MT equals 2k negative k, and the magnitude of MT is square root of 180. Find the positive value of k. If vector MT is 2k minus k, then its magnitude can be expressed as the square root of 2k squared plus negative k all squared. We've been told in the question that this is equal to square root of 180. From here, all we need to do is make k the subject of the equation. When we square both sides of the equation, this is what we get. 2k all squared is 4k squared, and negative k all squared is k squared. 4k squared plus k squared is 5k squared. When we divide both sides of the equation by 5 and take square root of both sides, this is what we get. We only take the positive square root since we are told to find the positive value of k. Square root of 180 divided by 5 is 6. Solve the equation f of x equals g of 1. We know f of x is 2x plus 1. To get g of 1, we replace x in g of x with 1. 1 squared plus 4 is 5. When we subtract 1 from both sides of the equation, we get 2x equals 4. When we divide both sides by 2, we get x equals 2. Find f inverse of x. We know f of x is 2x plus 1. In the first step, we replace f of x with x and replace x with y. When we make y the subject, this is what we get. This result we have for y is the same as f inverse of x, which means f inverse of x is also equal to x minus 1 over 2. Find g of f of x in its simplest form. To get g of f of x, we replace x in g of x with f of x, which is 2x plus 1. To expand 2x plus 1 all squared, we square 2x, which is 4x squared. Then we multiply 2x by 1 multiplied by 2, which is 4x. Then we square 1, which is 1. 1 plus 4 is 5, and so our final answer here is 4x squared plus 4x plus 5. Solve the equation h inverse of x equals 0.5. We know h of x is 2 raised to the power x. Now we replace h of x with x and replace x with y. Y is the same as h inverse of x, which has been given as 0.5. So now we have x equals 2 raised to the power 0.5, which is equal to 1.41 rounded to 3 significant figures. 1 over h of x equals 2 raised to the power kx. Write down the value of k. H of x is 2 raised to the power x, so we can rewrite the equation as 1 over 2 raised to the power x equals 2 raised to the power kx. 1 over 2 raised to the power x is the same as 2 raised to the power negative x. Now that the bases on both sides of the equation are equal, then the powers should also be equal. This means x equals negative 1. The grid shows the graph of y equals cos x for x is greater than and equal to 0 degrees and less than and equal to 360 degrees. Solve the equation 3 cos x equals 1 for x is greater than and equal to 0 degrees and less than and equal to 360 degrees. Give your answers correct to 1 decimal place. When we make cos x the subject of the equation, we get cos x equals 1 over 3. Now that we've made cos x the subject, we need to find the value of alpha. the reference angle that will allow us to find all the possible values for x in the given range. We find alpha by taking cos inverse of the positive value of 1 over 3, which is the same as 1 over 3. When we type this into the calculator, we get the value of alpha as 70.5 degrees, rounded to 1 decimal place. Now we need to draw the quadrants. Since the value of cos x, which is 1 over 3, is positive, we are only going to use the quadrants where cos is positive, and these are quadrants A and C. The angle alpha is measured from the horizontal axis in these quadrants. When we go around the quadrant the first time, we get our first value of x as alpha, which is equal to 70.5 degrees. When we go around the quadrant the second time, we get our second value of x as 360 degrees minus 70.5 degrees, which is equal to 289.5 degrees. And so for our final answers, we have x equals 70.5 degrees and x equals 289.5 degrees. On the same grid, sketch the graph of y equals sine x for x is greater than and equal to 0 degrees and less than and equal to 360 degrees. On the grid, we've drawn the graph for y equals sine x, which you can memorize or plot some sample points to help draw out the shape. The diagram shows a trapezium ABCD. AB is parallel to DC. AB is 55 meters, BD is 70 meters, angle ABD is 40 degrees, and angle BCD is 32 degrees. Calculate AD. To find the length of AD, we apply the cosine rule to triangle ABD. This is what we get after applying the cosine rule. AB is 55 meters, BD is 70 meters, and angle ABD is 40 degrees. When we substitute these values into the equation and make AD the subject, this is what we have. When we type this into the calculator, we get 45.0 meters, rounded to 3 significant figures. Calculate BC. Since AB and DC are parallel lines, these two angles are alternate angles, and alternate angles are equal. Now that we know angle ADC is 40 degrees, we can apply the sine rule to triangle BCD to find the length of BC. This gives us BC divided by sine 40 degrees equals 70 meters divided by sine 32 degrees. When we make BC the subject of the equation, this is what we get. When we type this into the calculator, we have 84.9 meters, rounded to 3 significant figures. Calculate the area of ABCD. The area of ABCD can be found by adding the area of triangle ABD to the area of triangle BCD. The area of triangle ABD is equal to half of 55 times 70 times the sine of the angle between these two lengths, which is 40 degrees. The area of triangle BCD is equal to half of 84.9 times 70 times the sine of the angle between these two lengths, which is 108 degrees. When we type this into the calculator, we get 4,060 meters squared, rounded to 3 significant figures. Calculate the shortest distance from A to BD. The shortest distance from A to BD is the length of the perpendicular line from A to BD. We have labeled this length on the diagram as y. We can find y using SOHCAHTOA. This gives us sine 40 degrees equals y over 55 meters. When we make y the subject, this is what we get. When we type this into the calculator, we get 35.4 meters, rounded to 3 significant figures. show that the volume of a metal sphere of radius 15 centimeters is 14,140 centimeters cubed. Correct to 4 significant figures. We've been given the formula for the volume of a sphere as V equals 4/3 pi r cubed. In this case, we have the radius r of the sphere as 15 centimeters. So when we put this into the formula, this is what we have. When we type this into the calculator, this is what we get. The fourth significant figure is 3. The number after 3, which is 7, is greater than 1. And so we add 1 to 3, giving us 4. Then we replace all the numbers after 3 with 0. And so our final answer is 14,140 centimeters cubed, rounded to 4 significant figures. The sphere is placed inside an empty cylindrical tank of radius 25 centimeters and height 60 centimeters. The tank is filled with water. Calculate the volume of water needed to fill the tank. The volume of water required to fill the tank would be equal to the volume of the cylinder minus the volume of the sphere. The formula for the volume of a cylinder is pi r squared h, where the cylinder has radius r as 25 centimeters and height h as 60 centimeters. We already know the volume of the sphere as 14,140 centimeters cubed. When we type this into the calculator, we get 104,000 centimeters cubed, rounded to 3 significant figures. The sphere is removed from the tank. Calculate the depth d of water in the tank. The volume of the water will be equal to pi r squared times d. We want to find d, so when we make d the subject of the equation, this is what we get. We found the volume of the water as 104,000 cm cubed, and we know that the radius of the cylinder is 25 centimeters. When we type this into the calculator, we get 53.0 centimeters, rounded to 3 significant figures. The diagram below shows a solid circular cone and a solid sphere. The cone has radius 5x centimeters and height 12x centimeters. The sphere has radius r centimeters. The cone has the same total surface area as the sphere. Show that r squared equals 45/2x squared. We've been given the formula for the curved surface area of the cone as pi rl, and we've also been given the formula for the surface area of a sphere, which is 4 pi r squared. From the question, we've been told that the cone has the same total surface area as the sphere. Since we are dealing with a solid cone, the total surface area of the cone will be the area of the curved surface, which is pi times the radius, which is 5x, times the slant height, which is L, plus the surface area of the circular face at the bottom, which is pi times the radius, which is 5x squared. Then for the sphere, whose radius has been given as r, its surface area is 4 pi r squared. The final equation we want to arrive at does not contain L, so we need to replace L with an expression in terms of x. From the illustration, we see that we can find L by applying the Pythagoras theorem. This gives us L squared equals 5x squared plus 12x squared. 5x squared is 25x squared and 12x squared is 144x squared. 25x squared plus 144x squared is 169x squared. 169 is a perfect square, so we can rewrite 169x squared as 13x all squared. When we take square root on both sides of the equation, we get L equals 13x. So now when we substitute L equals 13x into the original equation, this is what we have. Pi times 5x times 13x is 65 pi x squared, and Pi times 5x all squared is 25 pi x squared. 65 pi x squared plus 25 pi x squared is 90 pi x squared. We want to make r squared the subject, so we divide both sides of the equation by 4 pi. Pi cancels out. 2 goes into 90 45 times and 2 goes into 4 2 times. We've been able to show that r squared is equal to 45 over 2x squared. A curve has equation y equals x cubed minus 6x squared plus 16. Find the coordinates of the two turning points. At any stationary point or turning point, dy dx is equal to 0. To get dy dx, we differentiate the equation of the curve, and this gives us 3x squared minus 12x, which we equate to 0. To get the x coordinates of the turning points, we can solve this quadratic equation by factorization. The common factor for the two terms is 3x. When we factor that out, we are left with x minus 4. When we equate 3x to 0, we get x equals 0. And when we equate x minus 4 to 0, we get x equals 4. To find the corresponding y coordinates, all we need to do is plug in the x values into the equation of the curve. When x is 0, y is 16, and when x is 4, y is negative 16. And so the coordinates of the turning points are 0, 16 and 4, negative 16. Determine whether each of the turning points is a maximum or a minimum. Give reasons for your answers. The second derivative helps us determine the nature of the turning points. To get the second derivative, we need to differentiate dy dx. dy dx is 3x squared minus 12x. When we differentiate this, we get the second derivative as 6x minus 12. When we substitute x equals 0 into the second derivative, we get negative 12. Since this result is negative, it means the turning point 0, 16 is a maximum. When we substitute x equals 4 into the second derivative, we get 12. Since this result is positive, it means the point 4, negative 16 is a minimum. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.